Okay, today we learned all about parallelograms. We even did our problem of the day that was based on parallelograms. So we're going to find the perimeter and area of parallelograms, and then we'll also do the same thing on the coordinate plane. So a polygon is an enclosed shape with straight sides. So we talked about what it means to be enclosed. This is not enclosed, so it's not considered a polygon. This is enclosed, but it does not have straight sides, so neither of those are polygons. We have what's known as a quadrilateral. This is a polygon with 4 sides and 4 angles that add to be 360 degrees. We have a parallelogram. This is a quadrilateral, so it has 4 sides and 4 angles whose opposite sides are parallel. So we would have parallel sides. Those two are parallel. That's what we show on a picture to show that they're parallel, as are these two, and these two are not parallel to this side, so we show 2 sets of arrows. And congruent, so to show that they're congruent we put a hash, we put 2 to show that these 2 sides are different than the other sides, and whose opposite angles are congruent. So let me get rid of those. We would say that these are opposite angles so they would be congruent. So if this first one is 60 degrees, the other one would also be. And then we talked about, well, what about A and B, those 2 angles? What do you guys think? And we came to the conclusion that they are, if we added them together, they would equal 180 degrees. And then we talked about the vocabulary word associated with angles that add to be 180 degrees, and that's supplementary. And we talked about when 2 angles add to be 90 degrees, those are complementary. So when it adds to be 180 degrees, that's supplementary. So there's a lot of information we can get from a parallelogram. Our next quadrilateral is a rectangle, and it is a parallelogram, so opposite sides are parallel and congruent. They're also parallel. And then they all have 4 right angles, so all the angles are exactly the same. They are 90 degrees. And then we talked about if they intersect right here, or they meet a right angle, then those 2 sides are what we know is to be perpendicular. And we talked about having opposite reciprocal slopes. So if the slope of this side, and it's not, but what if it was 1/2? Then to get the opposite reciprocal, we flip that and change the sign, so the slope of our other side would be -2. And we're going to spend a whole unit discussing that. The last one we have is a square, and I'll draw that above there to write all over it. A square has all sides congruent, so it's a parallelogram. Opposite sides are parallel, opposite sides are congruent. It has right angles because it's a rectangle. And then all of the sides are the same. So if this was 5, all of the other sides would be 5. And a square is also known as a regular quadrilateral. To be regular, all sides are congruent, all angles are congruent. The perimeter is the sum of the sides of a polygon. So we're going to add all the sides up on the polygon, and that will give you the perimeter. For area, we have several formulas. The first one we'll talk about is a parallelogram. A parallelogram is base times height. Wow, I keep trying to draw a rectangle, sorry. So we're going to take this base, but this side over here is not the height. The height has to be perpendicular to the base. So this would be what's known as the height. We will use this other length over here when we're looking for perimeter, but for area we do not use it. For a rectangle, on a rectangle, this is our base. We already know that those 2 are perpendicular, so this side is considered our height. And then for a square, all sides are the same. So instead of going base times height, we just say side times side, or side squared. So on example 1, we're going to find the perimeter and area of each parallelogram. So we have just a parallelogram here. Important to know that opposite sides are congruent. So the top side is 15, so the bottom is 15. That diagonal is 10, so the other one is 10. Or side, I shouldn't say diagonal. To find the perimeter, we add all those up. So 10 plus 10 and 15 plus 15 gives us 50 units. For our area, we're going to take our base, which is 15, times the height, and it has to be perpendicular, which is 8. 15 times 8 is 120 units squared. Okay, before I went over this, I went over some rules. We went over rules like this. If I take 2x plus 4x, we get 6x. The same idea works with square roots. So if I have 2 root 3 and I add 4 root 3, then I get 6 root 3. Okay, then we said if I have 2x plus 3y, I can't combine those because they're not like terms. The same idea works with 2 root 5 plus 3 root 7. Those are not like radicals, so we can't combine them. So understanding that, we will go on with this example. So we're going to start with finding the perimeter by adding all the sides. Now we know the opposite sides are congruent, so that's a 4. This bottom is a 10 root 2. So we have 2 4s to give us 8, and 2 10 root 2s. We add those two values together and we get 20 root 2 units. For our area, we take our base, 10 root 2, times our height, and we did this in our homework the other day. We multiply those outside numbers to get 40 root 2 units squared. Now you could multiply 40 times root 2 and give me the approximate value, but this is what's known as an exact value, so we're going to leave it as such. Okay, example C. I'm going to do this so that you know that it is a square. On a square, to find our perimeter, we add all the sides, and all the sides are the same, so we have 4 sides that are 5 root 3. So 4 times that 5 will give us 20 root 3 units. And for our area, we take side squared, or side times side. And we did this in our homework where we distribute that power to get 5 squared and root 3 squared. 5 squared is 25. Root 3 squared, remember they cancel each other. Those are opposite operations. So it gives us just 3, and we multiply those to get 75 units squared. Alright, moving on to our other parallelogram, and I did want to point out that we are finding the area of the parallelogram. That other information that's given is needed because we need it. So I'm going to identify opposite sides. This is 10. To find the perimeter, we need all of those side lengths. So if you notice, we're missing this side length. However, we have this information, and we have a triangle, even more specific, a right triangle. So using that information, if we're looking for that hypotenuse, we can take 8 squared plus 15 squared equals c squared. 8 squared is 64, 15 squared is 225. We add those to get 289. And then we take the square root, which is 17. And then we talked about how that was a Pythagorean triple that we have already talked about. So if we'd known that it was a triple, we could say, oh, that side's 17, and you wouldn't have to go through this work here. Oops. Okay, so moving on to the perimeter, we're going to add our sides. We have 2 sides that are 10 and 2 sides that are 17 to get a total of 54 units. For our area, we take our base times our height, and they have to be perpendicular. So the height of our, I drew that a little thick, the height of that is the same right here as 15. So we're going to take 15 times the base that it is perpendicular, and that would be 10. 15 times 10 is 150 units squared. Okay, example 2 says find the height and the base of the parallelogram if the perimeter is 100 meters. We're going to start out by labeling these other sides, 3x plus 4, because opposite sides are congruent. And the bottom is 5x minus 2. It tells you that the perimeter is 100 meters. So if we know our perimeter is 100 meters, we know that means we got to add up all our sides. So we have a 5x minus 2. We have 2 of those, so I'm going to put a 2 here. And 2 sides that are each 3x plus 4. And they all add up to 100. Okay, we'll distribute that 2, 10x minus 4, and distribute the next 2. 6x plus 8 equals 100. Combine our like terms. The 10x and the 6x give us 16x. The negative 4 and the 8 give us plus 4 equals 100. Then we're going to subtract 4 to both sides. We're left with the 16x equals 96. Divide by 16. And x equals 6. And then we'll go back and find out what it really wants us to find. It says find the height and the base. So really we're looking for the height and the base. So our height has a length of 2x plus 5. So we're going to replace that x with a 6. That's what we just found. And then add 5 from here, 2x plus 5. So 12 plus 5 equals 17. That is our height. And then our base is that 5x minus 2. So 5 times 6 minus 2. 30 minus 2 is 28. And that is our base. And we can see this is obviously not drawn to scale, but we'll use that information. On example 3, this is brand new. And there's actually a lot of principles I'm going to teach in just a few minutes. I won't expect you to master it. I just want you to try it. It says find the height and the base of the parallelogram if the area is 200. And we know the area is your base times your height. So my base is x plus 17 times my height, which is x. And this will be equal to 200. So the first thing you're going to do to solve this is distribute the x to give us x squared plus 17x equals 200. Then we're going to subtract that 200 because we have an x squared and an x. So if that ever happens, you want to get 0 on the other side. And then we're going to do what's called factoring. Because I have an x squared, that means I have to have 2 x's. So I put an x in both of the front of the parentheses. At the end I have this negative 200 and I have this 17, and those two numbers are very important. We're looking for two numbers that multiply to give negative 200 and add to give 17. So, negative 200, two numbers that multiply, that would be like negative 20 and 10. If I add those, I get negative 10. So that's not the right combination. I know that we have negative 25 and 7. When we multiply those, we get negative 200. When we add them, we get negative, sorry, it's 8, not 7, 17. Now, we got negative 17, but I need a positive 17. So I'm going to change the signs. If I take 25 times negative 8, I still get the negative 200. When I add them, I do get that positive 17. So I'm going to use those numbers. When I use those numbers, I put them in the parentheses as a positive 25 and a negative 8. Now, previous this year, we've actually foiled these. If we were to foil those, it would give us this answer here. We would take this x and multiply it by both, and take the 25 and multiply it by both, and it would then combine like terms, and we would get that trinomial x squared plus 17x minus 200. Now we're going to go a couple more steps with this. Because these are both equal to 0, or because it's equal to 0, we can set each expression equal to 0 and solve it. To solve the first one, we subtract 25. We get negative 25. That means if I put a negative 25 in for this x, this would give us 0. 0 times anything is 0, and that's why that negative 25 works. So we do that for the other equation, x minus 8 equals 0. So we add 8, and x equals 8. So if I put an 8 right here where that x is, 8 minus 8 is 0, times this expression here would still give us 0, and that's why 8 also works. So we're going to come back to our original shape up here and look at these values. If I have x is equal to negative 25, that says my height is negative 25. Now, we know that isn't true, so this isn't a right answer. And we've talked about these before where you can get answers, but they're not right when we go back to the original idea. They're called extraneous solutions, so that's not the right answer. But we can put an x or an 8 in for x, and that's okay to have a height of 8. And then we can add this 8 plus 17, and that gives us 25, and that is a real, sorry I can't write that, 25, a real answer. So our height was 8 units, and our base was 25 units. So again, I don't expect you to master these kind of problems. I just want you to try them and see how you do. Example 4, it wants you to graph these with the quadrilateral with the given vertices, and then decide what kind of quadrilateral it is, and then find the area in the perimeter. So A is at 0, 0, B is over 4 up 0, C over 5 up 5, and D over 1 up 5. Okay, when we draw this and connect all our sides, we can see that we have a parallelogram. There are some other ways that you could verify that. You could find the slope of this side and the slope of this side. We can see they're both horizontal, so they're going to be 0. And then find the slope of those two sides and make sure that they are both parallel. But we can see that they are. They're both, on both cases, it's up 5 over 1. So we see they have the same slope. From there, we need to find the area in the perimeter. So to find the perimeter, I'm going to show you something. We talked about this the other day, but we didn't do it. We can see that this side is 4 and this side is 4 because we just have to count those, but we don't know what this side is. But we can create a right triangle and use the Pythagorean theorem, or we could use these 2 points and the distance formula and find the distance between them, but the Pythagorean theorem is awfully fast. We can see that this has a side length of 1 and this has a side length of 4. And then we use the Pythagorean theorem, 1 squared plus, sorry, that's not 4. That is 5. That was my husband thinking he was being pretty funny right there, so sorry about that. Anyway, we know that that's 1, this other side is 5. So we take 1 squared plus 5 squared to find that distance, c squared. Well, 1 squared is 1 plus 5 squared, 25 is 26. We take the square root of both sides to get root 26 here. And that will enable us to find the perimeter. To find the perimeter, we add all the sides. So we have 2 sides that are 4 to get 8, and 2 sides that are root 26, so 2 root 26. And the area, we're going to take the base, which is a 4, times the height. And we know that that height is a 5. 4 times 5 is 20 units squared. Okay, that should help you with your assignment. 8-3 parallelograms. Good luck.